Whoa, you know, Jake, this homework is really scary. Oh, my battery died. Again. I say it is time to go green.
I look good in green.
Wind power.
We really wanted to build our own mini wind farm and power something.
We're halfway.
We were just really awestruck at the size of these huge wind turbines.
Wow.
It's natural, and we're not taking away anything from the Earth.
Next on SciGirls.
That's right.
Funding for SciGirls is provided by the following. The National Science Foundation, supporting education and research across all fields of science and engineering. The National Science Foundation, where discoveries begin.
Math and science are everywhere. They're the building blocks of tomorrow. That's why ExxonMobil sponsors programs to get kids excited about math, science, engineering, and technology. So one day they may become the scientists of the future.
SciGirls! We need SciGirls! Come on!
When I need help and I've got a question, there's a place I go for inspiration. Gotta get to the web, check the girls' investigation. One girl. SciGirls! Woo! SciGirls!
I need you!
SciGirls!
Come on!
You got log on, post, upload, pitch in.
Yeah!
Wanna get inside a world that's fascinating? The time is right, 'cause SciGirls are waiting. SciGirls!
We need
SciGirls!
SciGirls! Whoa, you know, Jake, this homework on our depletion of Earth's resources is really scary. I say it is time to go green.
I look good in green.
Jake, hello? Do you, even listen to me at all?
Sure, mostly. It's just, I'm focusing on how many coins I can catch off my elbow. Going for the world record, and you're my witness. So, Iz, keep your eyes glued.
Okay, but... Oh, my battery died. Again. Darn. Maybe I can come up with a greener way to power this thing. Okay, plugging in one more time.
I did it! Just need one witness for it to count, and you saw it! World record, here I come!
Sorry, Jake. I didn't see it. I gotta go fix my computer, bye!
Wait!
I'm gonna need some help if I'm gonna figure out another way to power this thing. I need some SciGirl brain power. Right away! Let's see now. Aha! Whoa! Wind power? I think these girls can help me.
It's windy! Nikki and Vicky and Aditi and I all met at a science, technology, and engineering summer camp for girls. We learned about wind energy, lots of science stuff. It was really fun.
The girls are really high energy, and they're really nice. They're really awesome to work with.
The thing that fascinates me most about wind is that it's completely natural, and we're not taking away anything from the Earth.
I like wind energy because it's not something that you expect to be used for power, but when you see it in action, you're kind of like, that was genius.
So all four of us are pretty excited about wind energy.
Our mission for this project was to have a wider understanding of wind energy.
Because we really wanted to build our own mini wind farm and power something.
It doesn't have to be this great, huge idea. It can be just something small, and it'd still be as cool. We're gonna set up our own mini wind farm, and I can't wait to see what we power.
Woo! You guys, I'm so excited!
It's gonna be so much fun! And we read about this sculpture at a museum, and it was called the Floating Gardens, and it was powered by wind, so it was really cool.
Whoa. Cool. Is that real grass?
Wow, look at that!
That's cool.
So the wind turbine is powered by the wind, and then that makes the battery, that gives energy to the battery, which powers the pump, which powers the irrigation system to make the grass grow.
I don't know, I just like how you can see everything, because it makes a whole lot more sense, because you just see that and you're like, what is this doing here? And then you see the battery and it's like, oh.
It's because it's like scientific but artistic at the same time. So it's like a twofer.
You can see everything.
Next to the exhibit, because then you can kind of make sense of it.
Yeah.
It was this masterpiece. It was really cool to see how we could use natural resources to make something so beautiful.
So it looks like there's a pattern going around the balloon. It's like a prism inside.
Looks like the wind is going through It's almost like he's showing where the wind's going and how it works.
It kind of.
Maybe the artist wants us to think of extending this to the world.
Yeah. One day the city, the next day the world.
After seeing the exhibit, all 4 of us were really inspired to go out and build a mini wind farm. So we went to Kid Wind because we knew that they had those mini turbines that we could use that we also used at camp. So we had some experience with using them. The warehouse was this big room that they had all of their stuff that they made in there, and they had tools. They had like the gears for the turbine in one box, and then the pump for if you wanted to use water. And they had the base and the tubes and little plastic cardboard that you can use.
Blades. Wind turbines.
So cool.
The base is connected to the shaft. The shaft holds the nacelle up, and the nacelle is where the generator is, and that's what the blades turn to power the generator to make energy.
We have our wires for transferring energy.
To see how many volts we can make with the generator.
All right, you guys, why don't we start working on the blade design? We used a rectangular plastic cardboard. We are going to attach the blades to the wooden dowels using hot glue.
To work with the hot glue gun, it's really hot and you have to be very careful with it because otherwise you'll burn yourself, as I found out. We're gonna try to see how many volts we can get with just a plain rectangle. There we go.
Next blade on. Why don't we use it without an angle first, just to see if we need an angle to begin with?
Wiring our very first turbine to the voltmeter just kind of gave us a little bit of a familiarity with the equipment that we were using.
Yes, fingers crossed.
Let's go. Uh-oh.
Yeah. Uh-oh.
Yeah.
SciGirls, you better reevaluate.
Maybe we need an angle.
Maybe a little tilted to the right. All right.
There we go. It's working.
It's working. I think we should design a vane to keep it straight.
What if we did an L-type thing?
There we go.
If we have it at a right angle, it will be perpendicular to the pole, and so then it will be able to study the movement of this more.
Let's test it.
Perfecto.
Looks good.
First, we started out with a 40-centimeter rectangle. It didn't work very well.
So we should probably downsize it.
Yeah, definitely.
A too short blade wouldn't be as efficient.
Yeah.
And too long will be too heavy.
Yeah. So medium-sized blades would be the best option. We shortened it a little.
Plastic cardboard cut. There. All right, so the blades are now 25 centimeters long, people.
That is
Pretty fast.
And there we go.
That's our fastest yet.
Yeah, most
And it's our
definitely.
first time doing the shorter blades.
Yeah, this is a lot better than it was.
Yeah, medium blades were a great idea.
Yeah.
Wow.
High fives all around.
Yeah.
The reading is about 1 volt.
All right, so if we put it at more of a steep angle, then maybe if we do one trial, if we have it really steep, and the next one we have it almost flat, see the differences?
Sure.
Yeah.
Let's go for it.
I mean, if it fails, that's what science is, trial and error. We have a protractor, 50. So,
It's not spinning that fast.
I know.
No. So let's try and shallow it out a little.
30. Whoa. By 10?
Yeah.
That one's going really fast.
Oh, wow.
Wow, that's really fast. The reading is 1.7 volts.
Oh my gosh.
Yeah.
So when we make our turbines, we should make sure that all the blades are exactly 10 degrees for the maximum effect.
We decided that we're going to change the shape, and so we cut it down a bit, made it more aerodynamic.
The actual blade that we came up with, it kind of curved at the end, sort of like what you do to spread icing on a cake.
Our design is so that it curves up to a point at the top and eventually gets narrower so that we can get less drag and move faster for more energy and volts.
Why don't we curve it?
Yeah, let's try curving this.
Because airplane wings are curved, and they seem to reduce the drag.
To curve it around our hand.
That seems to be going really fast now.
All right. So the reading is 3.7 volts.
Wow.
So in the end, the blade was efficient, it was well designed, it was aerodynamic, so it had everything tied in together to make the perfect blade.
So this design is officially the design that we are going to use on our 20 turbines.
Hey guys, let's just start by wiring 2 together.
Let's go.
Awesome.
Awesome. We doubled the amount of turbines. We doubled the fans, so now we're gonna get double the voltage.
The voltage reading is 7.1.
We thought it was going to be around 7.57, and it was 7.1. And it must have lost some energy when going through, so it's not going to be perfect. We put the mini turbines one in front of the other, and once the wind started going from the fans, the first turbine kind of obstructed the wind flow, and then the second one didn't work as well.
The voltage reading is 5.7 volts, so not quite 7.
Yeah. So it is going slower. We decided that we were going to have a staggered placement.
You'd have another one right here.
Yeah.
Oh yeah, that's
So, because then we could catch as much wind as we could, but then minimize the space that we had to use. We kind of got the idea that we could power a water pump with it. Why don't we power like a bird bath when we set up our wind farm?
Let's do it.
So cool. Yes, wind powered.
And making little fountains in the bird bath, there was no debate. We just agreed on a bird bath.
So it's really cool how we found our blade design in there and the voltage and everything.
We needed to learn more about wind energy.
We realized we'd probably need some help and we probably need to see an actual wind farm so we're not doing this wrong.
Yeah. We should really go see real wind turbines to see how we should set up ours.
Woo! Let's go! Hi, I'm Hannah.
Hey, Hannah.
I love basketball. It's my favorite sport. I'm not very tall, but I'm the tallest girl on our team. So this is my little sister, Sophia. So this is my room. These are my awards. I have my skating awards and science fair. So these are drawings from school. So I love the great outdoors, so climbing trees, and I want to be a pediatrician for special needs kids. Adios.
So we needed to learn more about wind energy and how it worked. So we went to a real wind farm.
Are you Mallory?
Yeah, hi ladies, how are you?
Good.
We needed to find someone to help us, and that was Mallory.
Today we're at Crane Creek. This is a wind farm under construction. It has 66 wind turbines, so it will be a great place to learn about wind energy. Come on guys, let's go check it out.
Yeah. Holy petunia, that thing is massive.
Yeah, and that's just the first part of the tower. Can you imagine how tall it's going to be when it's fully constructed?
Wow, that thing is tall.
I don't know, I'm guessing taller than the Statue of Liberty.
It will be. It's about 120 meters when it's fully put together.
It looks like a giant toothpick.
Feels
Good one.
It's smuff. We were just really awestruck at the size of these huge wind turbines and how big the blades were. Scooch out toward us.
Not even halfway.
I knew they were big, but being standing right next to them, it was just wow. And it's hollow.
Hollow.
Wind power.
I wonder how many thousands of meters of wire go into making these wind farms.
A lot. When someone first decides they want to build a wind farm in this area, it can take 2 to 3 years to get a wind farm up and running, if not longer. This turbine by itself is going to power 450 homes. A lot of wind farms can be up to hundreds of turbines. It can kind of vary on how much energy a particular wind farm needs to produce.
The crane putting the blades on top of the tower was a sight to see. We were kind of wondering how they were going to get up there with just one crane.
And we were looking at it, and all of a sudden we see this guy standing on top of the nacelle, and we're like, oh my gosh.
This site in particular that we're looking at is good because it's not close to any wetlands, it's not close to any roads, houses, airports, archaeological sites, and it's a good wind resource. A lot of things really go into deciding where this turbine's gonna go.
And then once we got to the second wind farm, we're like, oh, so this is how it's gonna look.
Here we are at Grand Meadow. This is a fully functioning wind farm with 67 turbines on it.
So how come the turbines are moving?
Well, right now we're pretty close to the ground. What we're getting down here is a lot different than what they're getting up there at 400 feet up compared to 5. Wait, how tall are you?
5 feet 1.
Okay, well, yeah, it's a lot different from 5 feet to 400 feet. Up here on the top, we have the wind turbines. The wind turbines are connected underground through cables. The energy comes down through the turbine and underground to what's called a substation. And all the energy gets all mixed together at the substation. And then it gets carried out to the nearby communities and houses through above ground power lines and transmission lines.
So is the substation kind of like a battery?
It's not quite like a battery. It doesn't really store the energy. It more just collects it all.
When we were sitting there talking, we would look back and we would see that some of the wind turbines weren't moving, and all of a sudden they would be moving. So the wind was fluctuating a lot.
The wind must have really picked up again.
Yeah.
Isn't that interesting how the turbine can kind of, slow down and speed up? It's not consistent.
So it's a good thing that the wind turbines aren't closer together, because then they'd hit each other.
Like this? this? Ow! Ow! So we decided that we're going to put our mini wind farm on top of a ski hill. And we decided that because it's high up when we get a lot of wind, even though it's not the greatest spot for an actual wind farm, it would be great for a mini wind farm.
So we're gonna have to do some testing on your wind farm up there on the ski hill.
Yeah, we'd love if you would come with us.
I'd love to, I'll be there.
All right, awesome.
Hey, let's go visit the website.
Push the button, push the button.
Why don't we work on our project page?
Yeah, sounds good.
Look at there's Izzie.
Oh, she's so cute.
All right, so why don't we take one of Izzie's quizzes?
All right.
Cool. Favorite pairs of shoes? A, boots, B, fancy dress-up shoes, C, sandals, or D, none. I prefer to go barefoot.
How about E? All of the above.
Guess I'm kind of a tie between like sandals and none.
Sneakers all the way.
Oh, yeah.
Ooh, let's check out their profiles.
I'm Nikki, and this is my new puppy, Lucy.
Hi, Lucy.
I love softball, basketball, soccer, and a lot of sports. This is my mom, and we're working together to be a little bit more green. I've been trying to get my parents to turn off the air conditioner in the summer. Rain doesn't only save the planet, but it also saves energy and money. See ya!
See ya.
So now it's data collection time.
Okay, we should start by collecting data on 2 spots on the hill, and we should look for average wind speed and max wind speed, and we should collect for 10 minutes.
Yep, we'll be down here.
And we'll be up there.
We're halfway to halfway. Here we go. No, we're not going all the way up there.
We're not? There we are.
This was quite a workout.
Oh, yeah.
Okay, so what's our location on the hill?
The coordinates are north 44 degrees.
And 51.309 minutes.
The wind is coming from the east.
An anemometer is this handy little technological device in which we use to calculate the wind speed.
10 minutes starts now. Go! Okay, let's start.
All right, wind speed time.
0
It's
miles.
gonna be a long 10 minutes without any wind.
Yeah.
Oh, yeah.
Come on, move, please.
Still no wind.
So hard to collect data on wind when there's no wind.
Pretty bad. But it was a great view at the top, so I just made up for it all.
At the bottom of the hill, there's not a lot of wind. And if there is wind, it comes in small little gusts at random moments and you can't really track it. I hope that the wind farm works. I believe that it will. It will stop at random moments, I bet, because of the wind and the gusts. But I'm pretty sure it will work. We'll find a way to make it work.
It was really, really cool that Mallory was there. It was lots of fun. What's your actual official title?
My official title is a GIS specialist. GIS stands for Geographic Information Systems. I analyze data and figure out where to put wind farms.
So what got you interested in wind energy?
I interned with the National Weather Service, so I learned about wind and weather and forecasting, and it kind of progressed from there.
Awesome. As a kid, were you always interested in science?
I was. I would go outside and fly kites, kind of like you guys, and watch sci-fi shows, and
Mallory became our friend along the way. Instead of a mentor, we could easily approach her and ask for help, and she was always there for us.
Pray for wind! Hey, I'm Vicky. So this is my room. Over here I have my awards. This is from winning first place in my district in the spelling bee. So my parents came from Nigeria, which is this kind of smallish country in Africa. I really, really like music, and I just got the guitar. I'm not the best at it right now. I'm still kind of learning. I've been playing the saxophone for 4 going on 5 years. So the last time we went to Nigeria, we got to go to a tailor and he custom made some native clothes for us. Okay, so here's my family. Okay, so it's time for us to say goodbye. So I'm going to say it in Nigerian. Odabo.
All right, so day 2 of data collection.
Yeah, and look, it's windy.
Yeah, finally.
You ready? 10 minutes starts now. Go!
All right, go.
Okay, we're going at 5 miles per hour. 10 miles per hour.
Yes, wind.
2.5. Oh, now it's 6. Oh, here it goes a little. 10. There's no way we could power a wind farm with this inconsistent wind down here.
The wind is really gusty today. It's all over the place.
All right, let's raise it up to see what we get at a higher altitude.
That sounds good. So we took the readings at 2 heights, one at 1.4 meters and another one at 2.4 meters. 10 minutes starts now.
Right now it's going at 10 miles per hour.
6.5.
5.5.
All right, our reading is 3.5.
12. 13. 15. 15.
Today we found that the wind speed is a lot faster when you go higher up in the air because there's probably less turbulence and there's nothing obstructing the wind.
With the test, when we had it at the lower level, the speeds weren't consistent at all. But once we got higher, the speed seemed to go more consistent and we had a bigger wind speed. So should this be the spot where we put the wind farm?
I think so.
Hi, I'm Aditi, and this is my room. Actually, Aditi has a pretty cool meaning. It means mother of gods. This is my sister Divya. When we were younger, we had a secret club called the FSS, and it stood for Best Friend Sister Sister. So we're looking at our pictures from one of our trips to India, and one of the coolest things to do is go bathe in the Ganges River. I like to do art, and I play volleyball, and I'm also in the orchestra.
Oh no, I forgot. I have to go to volleyball practice. Bye.
So why don't we recap our data?
Okay, our blade length was 25 centimeters.
Okay.
Our blade shape was the shape of an airplane wing, kind of like the scooper. The angle was 10 degrees.
So we should put all of our wind turbine blades at 10 degrees to get the optimum voltage.
That sounds right. Do we still want to use 20 turbines?
I think maybe we should downsize.
Yeah, because we have limited space.
Maybe we should try 15 instead of 20.
Yeah, that sounds good, because that way we can make 2 rows. One could be 8 turbines and one could be 7. So we for sure are putting our wind farm on the top of the hill, right?
Yeah, because on the top of the hill, it's faster wind and more consistent wind compared to the bottom of the hill.
Okay.
So the max wind speed for the top of the hill. We knew after we collected the data that the top of the hill would be the perfect place for the wind farm.
So this is the layout of our wind farm. We have 8 in the first row and 7 in the back row, and they're in a line, but they're staggered.
Right. Staggered. Remember, staggered. Better for the airflow.
So now that we have our map all done, to the top of the hill for our wind farm. 1, 7,
4,
1,
5,
8.
6, 7.
Okay.
8.
Okay, we need to like spread them out like major
Because it's
times.
flat right there.
Okay.
Yeah. How close can we put them? Can we put them here?
Don't let him hit.
So this looks like the map we made, doesn't it?
It sure does.
All right, so we'll take the front row. You guys can take the back. Sounds good?
Yeah.
All right, let's go.
Mallory came and helped us with the wiring. It was lots of fun.
Okay, so what we want to do is we're going to hook the red to the black, but we want to use the alligator clip to go in between.
Series circuits are, I think, the easiest circuits to wire because all it is just connecting black to red in like a ring.
So there we go, black to red.
So one black from one turbine will connect to the red of another turbine, and it pretty much just goes around in a ring until you have one black hanging from the one end and the red hanging from the other end.
It's moving. That's wind. In motion.
Go, Vicky.
Movement turbine.
Go, Vicky.
That's right. Yeah.
Yeah. These girls sure know how to go green.
How many volts now?
64 volts.
Look at how much fluctuation we're getting in the wind.
So Mallory, what do you think?
I love it. I love it. This is a perfect spot for this experiment. Maybe not a real wind farm, but for this experiment, perfect. What was our maximum voltage today?
70 volts.
70. Well, each water pump can only withstand about 12 volts. So how many are we going to need?
About 6?
Exactly, 6. So let's get it set up.
All right.
Okay, what we're going to want to do is stick the wires through the bird bath so we can get our pumps in the right place.
All right, and then we could tape the wires down with electrical tape because of the wires in the waters.
Exactly, no water on the wires. Okay, now what we want to do is hook the wires together so that we can hook it up to our wind farm.
Here comes the water. Almost there. It's going to be so cool.
I can't wait for the pumps to start working.
I'm excited.
We do like a drum roll. Had a little bit of problem from the turbines to the pumps in the bird bath. We knew we had to rewire them. So instead of having all 6 pumps connected to all 15 turbines, we created 3 circuits in which 2 pumps were connected to a group of 5 turbines, and that worked a lot better.
All right, ready?
See what happens.
All right.
All right, come on, birdies. We're open for business.
We have real wind powering wheel turbines, powering real stuff.
There we go.
As the wind fluctuates, so does the water flow.
Yeah, like right now. So the wind blows the turbines, which creates energy, which goes through the circuit of the wires, to the pump, and the pump pumps the water out into the fountain.
And we have this.
Woo!
I couldn't believe it actually worked. I was so excited and happy. It was amazing.
I'm glad that we chose the top of the hill because we ended up getting a lot more wind up here than we did down there.
It's an exhilarating feeling to feel the wind on your face and knowing that it can power all these different things like a bird bath, which we saw today. It's just so cool.
Wind can power almost anything. I mean, it's free, it's an easy source, and it's just everywhere. If you want to power something, just use wind.
Wind energy! You guys blew me away! So, the wheels turn a generator that powers my computer.
Cool.
Yeah, so you said you would help me in any way you could.
Sure, whatever you need. Wait, I'm your source of alternative energy?
Yep. Your legs are going to zip me right off the grid. Well, that's good, but you're gonna have to go faster than that. Oh, perfect. Just keep that pace.
Are you done yet?
No, I gotta rewrite the
I'm
last
going
page.
as fast as I can.
No, my computer. You know, Jake, being green may not be easy, but it is important. Now, put the pedal to the metal.
Would you dearest care to know the wind speed?
Of course.
It is going at a precise 1.5 miles per hour.
Blimey.
Splendid.
I do say that's tip-top.
Jolly good.
Jolly good.
We're on a wind farm here, and we're seeing some similarities. We got the corn, we got the sky,
Wind turbine.
just like being on a farm. We're harvesting wind.
Wind energy.
Wind.
Swimming with dolphins for the first time was very exciting.
We're looking at the mirror so we can determine where the dolphins can see themselves.
How many things that were thrown in the trash that could have been recycled?
Number 5, plastics. They are not recyclable.
If you guys created something, we could mark it.
This is our
Seed starting kit. We sketched a dress, and it had a lot of cool elements in it. Superhero princess. Thought maybe you could incorporate technology into fashion or garments.
Funding for SciGirls is provided by the following. The National Science Foundation, supporting education and research across all fields of science and engineering. The National Science Foundation, where discoveries begin.
Math, science, and curious young minds. They're our future. That's why ExxonMobil and former astronaut Sally Ride created the Sally Ride Science Academy to help teachers inspire our students so they may become the scientists and engineers of tomorrow.
Hey there! Hi! The SciGirls website is off the hook. You can set up a profile, find new friends, create a page for your science project, watch SciGirls videos, and have fun. So come on, be a SciGirl on pbskidsgo.org. See you there! Bye!